This is part 2 of section 4.1. We want to talk about decimal degrees versus degrees, minutes, and seconds notation, which we shortened to DMS. Today, we commonly write partial degrees in decimal degree notation. But traditionally, and especially on maps, you will see degrees, minutes, and seconds. The relationship between degrees, minutes, and seconds is very similar to the relationship between hours, minutes, and seconds. 1 minute is 1/60th of a degree, just like 1 minute is 1/60th of an hour. So a 1 degree angle is 60 minutes. And just like a second is 1/60th of a minute, or 1 minute equals 60 seconds, you have the same relationship here. So 1 degree has 60 minutes, and then this is broken down into 60 seconds each, which gives you 3,600 seconds. Okay. So let's talk about how to convert degrees, minutes, seconds to decimal degree notation, and we want to round it to 2 decimal places. Okay, what I'm going to do is to write this as a series of fractions. 13 degrees plus 9 minutes, so that's 9 out of 60, 9 over 60, plus 22 seconds, that's 22 over 3,600. Okay, and if I use a calculator to add these, we get 13.156111 degrees. We are asked to round to 2 decimal places, so this is approximately 13.16 degrees. Okay. Now what we want to do is to go backwards. If I am given a decimal degree and I want to go to degree, minute, second notation. Okay. What I'm going to do, first of all, I have the 41 degrees, just like this 13 was right here. No calculations were required. I definitely have 41 degrees. What I need to do is to figure out how many seconds and minutes this decimal represents. So what I'm going to do is to multiply 0.275, which is just the decimal portion of this. I'm going to multiply this by 60. And that's going to tell me roughly how many minutes I have. It gives me 16.5. Now what I'm going to do is I'm going to take the whole number part of this, 16 minutes, and then I'm going to repeat this. Basically the same thing I did here. I'm going to take the decimal part that's remaining, 0.5, and then so I have half of a minute. So half of a minute is half times 60, which is 30. So this is 30 seconds, and no rounding was required. Now, many of you will have a calculator that can do this for you. I have a selection here. Okay, let's try these 2 first. If you have this calculator, the degrees, minutes, seconds is handled under the angle. So you're going to have to hit second and then angle, and you'll see that you have the notation here. And if you scroll down far enough, it will convert back and forth. Okay. This calculator, it is hidden under the math menu, and you can see DMS over here, and you have the same options. If you have a graphing calculator, a TI-84, then everything you need is hidden under the angle button. So you'll hit second and then angle, and you can see everything you need right there. Okay. Now, degrees are how we think, but they're really not, it's not the best form for us mathematically. Once you go into calculus, virtually everything you do is going to be dealing with an angle measured in radians rather than degrees. And so the definition of radian: an angle whose vertex is at the center of a circle, okay, is called a central angle. So here I have central angle. I have an initial side here, terminal side here. You can imagine this on the x and y axis centered at the origin. Our angle measured in the positive direction is theta. A positive central angle that intercepts an arc of the length equal to the radius of the circle is said to have measure 1 radian. So basically, here's our radius length, and then this measure along this portion of the circle, if they are the same, then this is 1 radian. And here you can see that the circumference of a circle we know is 2 pi r, which is approximately 6.28 radians. Because here's 1, 2, 3, 4, 5, 6, and a little bit. The radian measure of a central angle that intercepts an arc of length s on a circle of radius r is defined by theta equals s over r. So if we know the arc length of an angle and we know the radius, we can determine the number of radians. So here we have an example. We know that we have a 100-degree angle, and if our theta here would be pi radians. Okay? This is s divided by r. We have that. Okay? Now, we will often be asked to convert between degrees and radians. So here we have our basic relationship here. We need to remember that 180 degrees equals pi radians, and then we can convert back and forth. Okay?